Welcome to Ekeeda. In this video lecture, we are going to discuss formation of Y-bus matrix by using step-by-step method. As we know, the Y-bus matrix is very important to carry out the load flow study. So it is important to know the different methods to formulate the Y-bus matrix. So one of the important method is step-by-step method. So let us understand how to calculate the Y-bus matrix by using step-by-step method. Okay, we have seen why we are using Y-bus matrix to carry out the load flow study. Why we are not going for the Z-bus matrix that we have discussed in our previous lectures. And of course, we have seen one of the method to formulate or to calculate the Y-bus matrix. It was direct inspection method. Now here we'll be discussing or we'll be dealing with the step-by-step method to formulate the Y-bus matrix. Okay, of course, in this method as well, we are not going to assume mutual coupling between the transmission line. So I will write this point here. It is important to note here. Assuming no mutual coupling between the transmission lines or between the lines. Okay, so we are not going to assume or we are not going to consider the mutual coupling between the transmission lines. Okay, without mutual coupling between the lines, we will be discussing the calculation of the Y-bus matrix using step-by-step method. So of course here we have to follow some steps. Okay, so I'll enlist those steps first, then we'll discuss those steps in detail. Of course, in this method, we'll be considering different steps. So I will enlist the different steps first, then we'll discuss those steps in detail. Okay, so let me write those steps here. The very first step here is, of course, whatever power system we are considering, its Y-bus will not change. The approach of finding the Y-bus, it may change. The Y-bus will not change. Whether you are going with the direct inspection method, whether we are going with the step-by-step method, or we are going with the singular transformation method, the Y-bus matrix, it will not change. Of course, as Y-bus matrix is not going to change, its order will also not going to be changed. Okay, so what we have to do initially, set all the elements of the Y-bus as 0. This is the first step. Initiate, or I will write initially, set all the elements of Y-bus as 0. Okay, of course, the bus or the Y-bus, whatever we have, it will have an order of n by n, where n is the number of buses. Our approach may change, but the matrix will not change, and of course, its order will not change. This is the first step. Keep all the elements, make all the elements of Y-bus as 0. Now, the second step, addition of an element of admittance Y will affect, okay, between ith and jth bus, between which nodes or which buses we are adding an element, that is important to note here. Addition of an element of admittance y between ith and jth bus will affect will affect it will affect the four entries or the four elements of the y bus. It will affect, as it is been added between ith and jth bus, so it will affect these elements: yi, yj, yij, and yji. These four entries or these four elements of the y bus will get affected on addition of an element of which is having an admittance y. Okay, see what we will do here. Whatever power system will be given to us, we'll take that power system first. First, make all the elements of y bus as 0. Then consider one of the element. Okay, and then see, after adding or after considering that element in the power system, how many entries or which of the element of the y bus it will affect. Okay, accordingly update update these elements in the y bus matrix. Okay, how to update that or how it is going to affect, that I will give you here, that idea I will give you here. It will affect yii in this way. Of course it will have some earlier value, as we are adding we are adding the very first element, so of course the initial value would be 0. So new value, it will be yii. It will have certain old value, of course, plus y. The admittance of the added element will add here. Okay, if it is yii entry, similarly yjj, yjj new, it will be, of course it will be same yjj old plus y. Okay, this is how it will affect these two entries. Now the rest of the two entries, let us see how it will affect the other entries. It will affect in this way: y I j new value would be same thing, y I j old value. Now here it is admittance between the buses. It is the admittance, or I can say self admittance, or the driving point admittance. It is the transfer admittance. So transfer admittance will change in this way: minus admittance of the added element will get subtracted from its old value. Same thing will be for yji, because it is also a transfer admittance. Yji old minus this admittance of the newly added element. Okay, this is how it will affect. Okay, so one by one we will consider all the elements connected between the buses. Okay, if an element which is connected between two bus, if it is added, it will affect these four entries in this way. Okay, so let us see how what happens if I add an element between the bus and the ground? I'll give that, I'll consider that in step number 3. Step 3, addition of an element of admittance y between, of course, I bus and ground will affect, see, it will affect only one entry as it has been added on the ith bus with reference to the ground, or if it is added between ith bus and the ground, it will affect only YII. Okay, it will affect only YII. How it will affect, or how it will modify this value? It is quite simple. Whenever you have a self admittance or the driving point admittance, then add the admittance of the new element. If it is a transfer admittance, then subtract the admittance of the new element. That's the idea here. New value will be old value. Okay, of course, it is a self admittance or the driving point admittance, and add the admittance of the newly added element. Okay, so this is how it will be, uh, it will modify the values. Okay, so one by one go on considering each elements. First consider the elements which is between bus and the ground, then you can consider the elements which are connected between two buses. Okay, this way consider one by one all the elements and go on modifying the values of the y bus. At the end you will get the y bus matrix. Okay, to give or to have a better idea or better picture of that in our mind, I'll take one example here. We'll consider one example. Of course, we are going to consider the same power system that we have considered in our previous lectures. Okay, example, formulate Y bus using step by step method for this power system, for this given power system. Okay, so firstly, uh, as I said, Y bus will not change. For a power system, its Y bus will be same. Only the approach is going to change. Okay, so here order of the Y bus will be, it will be number of buses. It will be decided based on the number of buses. How many buses are there? Here, n, that is number of buses. Your number of buses are 4. So of course, the Y bus matrix, whatever we have, it will be having an order of Y bus, 4 by 4. Okay, so our Y bus will have an order 4 by 4. So what is the first step? The very first step is to initiate the Y bus matrix, or the initiate all the elements of the Y bus matrix as 0 0. So 0 0 0 0 0 0 0 0. This is my Y bus matrix, and of course it has an order 4 by 4. This is the first step. Now, secondly, consider an element is being added between first bus and the ground. addition of an admittance y10. Okay, as suffix indicate, it is between first bus and the ground. Of course, the suffix indicate it is between bus 1 and the ground, between bus 1 and ground. So it will affect only one entry, is it? It will affect only one entry. Which entry it is going to affect? It will affect only y11. So y11 new value, it will become y11 old value plus this y10. It will affect this entry only, y11. Okay, so this new value of y11, it will become, earlier this old value of y11, it was 0, 0 plus y10, it will become y10. Okay, so now please consider or please save this value, y11 new value, you please save this value. Okay, now I'm going to consider the element, which is having an admittance y12, or I can say an element connected between bus 1 and 2. Okay, so let us consider that here. Addition of y12 between bus 1 and 2. Now, as it is being added between two buses, of course, it will affect the four values. It will affect the four values. Okay, so it will affect those values which are, the first one, it will be, as it is connected between bus 1 and 2, so it will affect y11. So the new value of y11, it will be y11 old value plus y12. See now here, y11, it is already been modified here, and its value is already, old value is y10. So the old value is y10, and the new, and this addition plus y12 will get here. Okay, so this entry has now got modified, y11. Okay, earlier it was 0 only, then it become y10, now it is y10 plus y12. Okay, now of course it is going to affect the four entries. The next entry that it is affecting, it will be y22, will get new value here, that is why suffix new I'm writing, y22 old plus y12. Okay, see earlier this y22 old is 0, 0 plus y12 will get here, it is simply y12 only. Okay, next it is y12, of course it will be again y12 old value, it is minus now because it is a transfer admittance, is it? It will be minus y12, so it will become, what is the old value? It is 0 only, minus y12, so I can say it will become minus of y12. Okay, so here in this y bus table, y22 got modified, y12 got modified. Of course, in next step we are going to modify y21. So these four entries will be getting modified, or these four entries will be getting affected on addition of one element. y21 new, it will be equal to y12 old. As it is a transfer admittance, minus will come here, minus y12. See here, earlier this value is 0 only, so minus y12, it will make minus of y1. So this is how the addition of an element between bus 1 and 2 will affect these 4 entries. Okay, if I update these 4 entries, then my y bus, it will become, if I update this my 4 entries, my y bus, it will become, what is y11? It is now y10 plus y12. What is y12? It is minus y12. These two entries we have not updated. This is also minus y12, y21, y22. Y22, it is plus y12 only. The rest of the all entries we have not modified here, or they are not, they didn't get affected still. Okay. So next, I'll consider an element addition of 2 y20, addition of y20. Okay, it means that this element which is having an admittance y20, it is being added between bus 2 and the ground. So of course it will affect y22 only. How it will affect? Y22 new value, it will be y22 old value plus y20. So it will be, what is the earlier value? What is the old value of y22? It is y12 only. Okay, so old value is y12 plus this y20. So now this value has got modified. Okay, now I'll consider, or I will consider an element between bus, let us consider the addition of element between bus 2 and 4. Let us consider that 1, 2 is 3, it will be 4. We are adding the fourth element now. See here, order is not important, means first we should add that element, then this element, then that element. That is not the case. You can uh, add any element at of your choice. You can decide the order of your own. Okay, it is not necessary that order uh, must follow some prescribed pattern. Okay, addition of an element which is having admittance y24. Okay, because there is an transmission link is connected between bus 2 and 4. That is why I'm considering it. Okay, so of course it will affect the 4 entries. How it will affect those 4 entries? It will affect y22 new will get here. How will get here? Y22 old value plus this y24. Same thing, it will affect y44 new value. It is going to be y44 old value plus y24 new. It will be y24 old plus, okay, it will be minus because it is a transfer admittance. Take care of it, huh? Minus y24, y42 new value, it would be y42 old minus y42. Okay, now how it is going to modify, how it is going to change? First thing is y22 new. Already we know what is the latest value of y22. It is y20 old value plus y12 plus this y24 will come. Okay, so we have modified this entry. Again, further we have modified this y22. Okay, next thing y44. Already it is 0. Y44 it is already 0. So we are modifying it. So what value we'll get here? We'll get simply y24 here. Okay. Next y24. Y24 this entry. It is anyway it is 0. So we'll get here 0 minus this y24. So we'll get minus of y24. Okay, y42 this entry. How it will change? It will get modified in this way, minus y24, because y42 old value is 0, and this is I've written here, I think it should be y42. I've written here 4, it should be 424. Okay, so you will get here minus of y24. Okay, so after adding this element, now my y bus matrix is now get further modified. Okay, how it got modified, let's see. The new y bus matrix or the modified y bus matrix we have with us now, it is the first entries are y10, y12, y10 plus y12. Here it was minus y12, 0 0 we had. Then here minus, of course we have minus y12. Now my y22 is now been modified. It is now this value, y24 plus y12 plus y24. Is it? So I'll write here y22 as y20 plus y12 plus y24. It is 0. Of course, y24 it has got modified. It has become y minus y24. Okay. This value we have not modified, so these values will remain 0 0. Here 0. Of course, y42 we have modified. It is minus y24 0, and here it is y24. Okay, so now we have considered only 4 elements. We have added only 4 elements, but we can add further 5 more elements. Okay, which elements we have considered? Let me mark out here. We have considered this element. We have considered this element 1 2. We have considered the admittance between bus 1 and 0. Okay, we have considered the admittance between 2 and 0. Similarly, we can consider the admittance between bus 4 and 0. In same way, we can consider the element connected between bus 4 and 3, element connected between bus 3 and 2, element connected between bus 1 and 3, and the admittance which is having element which is having admittance uh, between bus 3 and ground. Okay, so this way you can consider, or you can include one by one element, and you can go on modifying this y bus matrix or the elements of the y bus matrix. After considering all these elements, you'll get the y bus matrix. Okay, so this is how it is simple to calculate the y bus matrix. Okay, hope you have understood this. Okay, so thank you very much.